In this video, we are going to see about the normalization problems. Three normalization problems we have discussed here. One is min-max normalization, and another one is z-score normalization, and the third one is decimal scaling normalization. First one, let us discuss about the problem based on min-max normalization. Here, we have considered the data set. This is the given data set. A is equal to 1000, 2000, 3000, 9000. This is the high dimensional data present in the given data set. So we are going to normalize these data within the range of minimum value 0 and maximum value 1. So in min-max normalization, our minimum value of the normalized data should be 0 and the maximum value of the normalized data should be 1. So the formula for calculating the normalized data in min-max normalization is V dash is equal to, V dash is nothing but your new data, that is normalized data, which is equal to V is your old data and minus minimum value of A. A is your data set. So the minimum value of A is 1000 divided by maximum value of A. The maximum value of A is 9000 minus minimum value of A. So applying the values in the equation for first case, when A is equal to 1000, V dash is equal to 1000 minus minimum value of A divided by maximum value of A minus minimum value of A, which is equal to 0, which is the first value in your normalized data set. And then case 2, while A is equal to 2000, applying in the equation, then the second normalized data becomes 0.125. And in case 3, the value becomes 0.25, and in case 4, the value becomes 1. Hence, the normalized data we have calculated using the min-max normalization ranges between 0 to 1, 0, 0.125, 0.25 and 1. So this is a normalized data we have calculated for the given data set, given high dimensional data set using min-max normalization. So next one is z-score normalization. This is also the normalization, another normalization technique used for calculating the normalized data for the high dimensional data set. So here let us consider the given data set. X is equal to -5, 0, 23, 17.6, 9.2, 3.1 and 11. And this is a data set. And the variations between the data set is large. We have to normalize the data so that we can get useful information from the data set. So here the formula for calculating the z-score normalization is z is equal to x minus mu divided by sigma, where mu is the mean of the data set and sigma is the standard deviation of the data set. So we have to calculate the mean value. The mean value can be calculated using the formula sum of all the values present in your data set divided by n, which is the total number of values in the data set. So we have to sum up all the values in the data set and divide it by, there are 7 values in your data set, in the given data set, and I'm going to divide the summation by 7. So we get the mean value as 8.414, and the standard deviation, the formula for calculating the standard deviation is square root of summation of xi minus mu whole square divided by number of values present in the data set. So here x is your given data set and xi is nothing but ith value present in the data set. For example, x1 is -5, x2 is 0, x3 is 23, like that. Likewise, we have to substitute the values in the formula. So while substituting the values in the formula, we get -5 minus mu, the value of mu is 8.414 whole square. Since that is summation, we have to sum all the values like this, and the overall summation is divided by 7, which is the number of values present in your data set. And the value of this formula is 83.35, and the standard deviation can be calculated by finding the square root of this value. So hence the square root of the value is 9.13. So we have calculated the mean and the square root for the given data set. Hence we have to apply this in the equation. Z is equal to x minus mu by sigma. So for case 1, when V1 is -5, the normalized data become -5 minus the mean value divided by standard deviation value, which is equal to -1.47. So likewise, we have to substitute all the values for the other cases. So for case 2, when value is equal to 0, your normalized data becomes this. And for case 3, case 4, case 5, case 6 and case 7. So we have calculated all the normalized data values for the given data set. Hence the normalized data calculated for the given data set using Z-score normalization is minus 1.47, minus 0.92, 1.6, 1.01, 0.09, minus 0.58 and 0.28. So we can see the difference between the given data set and here the normalized data set. So there is mild difference between the data values present in the data set, and the minimum value is minus 1.47 and the maximum value is 1.6 ranges here in the normalized data. And the next normalization problem is based on decimal scaling normalization technique. This is also the another technique which is used to find the normalized data for the given high-dimensional data set. Let us consider the same data set we have used previously for the Z-score normalization technique. And here the formula for finding the normalized value is Vi dash is equal to Vi by 10 power j. We have to find the value of j such that the value of j should be a smallest integer, so that it has to satisfy the condition that maximum of Vi by 10 power j should be less than or equal to 1. So let us apply in the equation. First, let us take j is equal to 1 and apply in the given equation. So for the first value, the value becomes minus 5 divided by 10 power 1, which is equal to minus 0.5, which is less than 1. So it satisfies the condition. And for second value also less than 1, it satisfies the condition. And for third value, it is not less than 1. So it is 2.3, which is greater than 1. So the condition is not satisfied. Hence, we have to increment the j value. So hence take j is equal to 2 and apply in the same equation. Now the first value is less than 1 and the second value is also less than 1, third value is less than 1, fourth value less than 1, fifth value less than 1, sixth value is also less than 1, seventh one is also less than 1. Hence all the values satisfies the given condition. Hence the normalized data becomes minus 0.05, 0, 0.23, 0.176, 0.092, 0.031 and 0.11. So this is the normalized data for the given data set we have calculated using decimal scaling method. So these three are the techniques we have used for finding the normalized data for the given data set, and there are much more techniques available for normalization, solving normalization problem to find the normalized data. And in this video we have discussed three data normalization techniques. Thank you for watching the video.